Okay, here are the questions, at least here are the answers to the SAS mock exam that I sent you for the coastal chart work. If you read through your questions, you'll be able to see what we're referring to here, and here are the answers. So question 1 was asking us to convert a ship's compass to a true. And remember, this way around we're going backwards, so it means from compass to true we add east and we subtract west. On question 2, we're looking to go from true to compass, which means true virgins make dog company, add whiskey and minus ethics. So we add whiskey going from true to compass and we minus east. Okay, question 3, what you need to do, you go onto your chart and you can find the transit, the actual true number, by taking a bearing of that transit line over Lion's Head and Devil's Peak. And there we got 115, 26 degrees variation, we end up with a magnetic of 141. We had averaged 147 on our ship's compass, so the difference is 6, and it is going from magnetic to compass is higher, which makes it 6 degrees west. Question 4, if you have a look at the compass rose in the southwest sector of the chart, on my chart it was a 2015, it said the variation was 25 degrees 19 minutes west, changing by 6 minutes west each year, and that gives us a rounded variation of 26 degrees west in 2020. Okay, then question 5, if you have a look under the scale part of the chart, you'll see it says there a projection being a Mercator projection, and just below it the chart datum's Thyroid Clark 1880 MOD. Okay, let's go and have a look now at question number 6. Okay, question 6. So here we were told the helmsman was steering 280 degrees. So what is the question here? They're looking for set and rate of current. So it's pretty obvious. We already have a water track, so we need to adjust that line for leeway. So remember how we do that. The helmsman says he thinks he's going 280 degrees. The navigator comes out and looks behind him and says, but that's not possible. We have 10 degrees of leeway, and the wind is coming from the south-southwest, which means you are actually doing 10 degrees higher. So that's where we got our water track of 290. The log read 6 miles, so we thought we had gone 6 miles. But it turns out when we compared it to our course over ground of 273 and 5.5 miles, we'd actually ended up doing less. So the answer here is 175 degrees is our set, and the rate is 1.77 knots of tide. Okay, move on to question 7. Question 7, okay, first thing I do is I go straight to what's the question asking us, the course over ground. So straight away I know it's a course over ground question, which means I already have a water track, which means I already have to correct this line for my water track. So the helmsman again here, he says he believes he's doing 050 degrees because he's looking forwards. The navigator comes out and says, hold on, the boat has actually got a leeway of 10 degrees, or what we've got here, 15 degrees, and you are actually sailing 15 degrees higher, which means it's 065 degrees. So here we put our 065 in. Remember, we now have to do the tide at the end because we've already done this. We're trying to establish our estimated position over here, and we put our tidal stream on the end, and from that we can get our exact course over ground, which was COG of 5045 degrees, and a boat speed over ground of 5.83 knots. Okay. Moving on to question number 8. Okay, so the first thing again I do here is, what is the question asking me? The question is asking me, what is your true course to steer and your expected speed over ground? So straight away, because I know that leeway only ever applies to a course to steer water track, you know, that one, the line that moves above the water, I can't do anything with the leeway, which means the tide comes on at the beginning. So I create my course over ground that I want to steer. It's that line there, 160. Don't worry about the distance. It's all I've done is drawn a long line. I set my tidal stream at the beginning of 238 at 2.6 knots. I see that my boat can travel 6 nautical miles. So remember, we could go anywhere. If I did nothing for an hour, I would visualize I would start from here, but I want to cross this line, and I cross this line over here, which then gives me a actual course over ground, so a speed over ground, and I have a 135 course to steer before leeway. So there are a few things I need to do now. What is the wind going to do to us? I'll go and have a look. We've got a wind forecast that we're going to sail on a starboard tack, which means the wind's coming over this rail, which means we should point our boat towards the wind to make up for the wind, and there's 10 degrees of leeway. So our course to steer is going to be 145 degrees. Our speed made good, our expected speed is going to be around about 5.8, maybe 5.9, so anywhere between 5.8 and 6 knots. Okay. Moving on, question number 9. This is a question that has to do with trying to find a fix. You'll see one error in this, and it's basically as a result of the software that I'm using. If you were sharp enough, you would have picked it up. This arrow needs to actually come on this side. Okay, so once we've converted our numbers back to from magnetic to true, we should end up with a position of roughly that. Question number 10 is dealing with tidal heights. Okay, so it's all self-explanatory over here. We want to have a tide of 1.5. How did we get that? We said we had charted depth of 1.1. We've got a draft to 2.1, and we want to clear by 1.1. So we need 2.1 plus 0.5 less what we already have gives us 1.5. If I look at the tidal hours, and I'm looking for a tidal hour divided by 6, I end up with a 72-minute tidal hour. If I look at the range, I end up with a 3.6. I'm really working with the rule of 12, so I've got 0.3 increments. So this tells me I'm going to have between 1224 and 1336, I'm going to have my 1.5. At 1224, I've got 1.2. I need an extra 0.3, which is 1/3 of the 0.9 I'm getting in that hour. So that tells me I then need 1/3 of the 72 minutes to determine my time. 1/3 of 72 minutes is 24. Added to my 12.24, I end up with a time that I can come in at 12:48. Okay, moving on to question number 11. Okay, question 11. Yeah, this is about a time that we're going to cross paths. Okay, so what we've got here, that's me, the target, The target is going to run on a bearing of 110 true. In 1 hour, he is going to be at his dead reckoning. So there's our dead reckoning. 1 hour, he'll be 3 miles down that line. We take a bearing between ourselves and our target at the start. We carry that line over, transfer line to over here. And we want to see if our vessel can do 11 knots. Okay. We're going to end up crossing that line there. This distance from there to there is 9. So working on our distance, speed, time, I've managed to find a course to steer of 010 degrees, and I now need to find, if my speed was 11, the distance is going to be 9, and that's in 1 hour. That means 9 divided by 11, 9 divided by 11 is going to be 82% of 60 minutes. It's going to be 49 minutes at what time I'm actually going to cross paths. Okay, remember, it's all about, at any point in time we want to be we want to be on a collision course. Let's have a look at question number 12. Number 12 is all about dipping the lights. Okay, so we've managed to establish that when we converted our magnetic to a true number, that we were seeing the light at 034 degrees. We then said, well, if the light was 20 meters above the water and my eye was 3 meters above the water, I would be 12.8 miles away, rounded to 13, and my estimated position is there with my lats and longs right there: 33 degrees 44.8 south, 18 degrees 12.8 east. Okay, let's move on to the question number 13, multi-leg question. So 13a, pretty straightforward. I've got to convert my numbers from magnetic to true, and I find my position. Okay, so you should have got a position of around 33 degrees 49.46 south and 18 degrees 20.69 east. Pretty close to that. I'm not exact because this program I'm working with kind of overlays if I make it too close. We then decide at 11 o'clock we're going to aim for our waypoint, which happens to be 34 degrees 2.4 south, 18 degrees 14.7 east, which is 4 nautical miles due west of Kabonkelberg. So I used the 270 line and I found my 4 miles and I took my waypoint. My boat can do 9 knots. I've found a course that I want to steer of 201, and the distance is 13.8 nautical miles. So how long is it going to take me? Okay, 13.8, 9, and we're talking about 1 hour. So sorry, we're trying to find our time. Okay, so time is going to be 13.8 divided by 9. It's going to be 1 hour and 53% of the next hour. Okay, so if I work out that, it's going to be 1 hour and 32 minutes on a course to steer of 201 degrees. Okay, straightforward. Yeah, it's just a line, making sure they're just testing your ability to find your positions and do your chart work. C, they tell us now half an hour later they give us a GPS fix, and we find that our fix happens to be this line over here, and it's 7.05 nautical miles down the way. Now, if we think of 30 minutes, okay, which is our boat speed of 9, which is going to be 4.5 nautical miles, we would end up at our dead reckoning spot over here. So we can see quite clearly, we thought we'd gone less distance than we actually went, so the tide is with us, and we have a drift in half an hour of 3.4, and we have a tidal stream setting at 256. You can ignore that, it's just the reciprocal of that number. So that's in half an hour, therefore our drift is 3.4. Our rate is going to be double that because it's a whole hour, 6.8 knots. And our set direction is going to be 256 degrees. Okay, so going into the next question, the final one, it's really straightforward. It's just a new course to steer and a new course over ground. So we can literally forget about all of the previous information. It makes no difference to us because the question says to us, in the next hour, we still want to get to this waypoint, so we've had to create a new course over ground. We're still going to have our tide running at 6.8 knots, and it's going to be 256 degrees set. And our boat speed is now going to we're going to push a little bit of power on there, and we're going to do a boat speed of 10 knots. So very simple. If we did nothing for 1 hour, we'd visualize that we would have only started here, which means going anywhere 10 nautical miles. We want to get back on this line. So doing these sums, we managed to find a course to steer 139 degrees. We work out that from there to there is 9.2 nautical miles. When are we going to get to where we want to be? From there, from our waypoint to our fix is 7.8 nautical miles. So our good old little triangle calculation, distance, speed, is going to give us a time. So if we take 7.8 divided by 9.2, we have 84, call it 85% of an hour. So 85% of 60, it's going to be an additional 51 minutes. So 11:30 plus 51 minutes means our ETA is going to be 12:21. Okay, it's not that difficult. Just kind of stand back, understand the questions, don't get confused with all the wording, and yeah, you should be fine. If you've got any problems, re-look at this. Otherwise, give me a shout and we can talk about it.